Great. All right. Well, Dylan and InterLink, thank you so much for inviting me tonight. My name's Aaron. I am the owner of a small engineering company here in town called Pipeline Design and Engineering, where we don't design pipelines. That's our joke. So the name comes from my background. I grew up surfing in Hawaii. And there's a very famous beach on the north shore of Oahu where I spent some time called Pipeline. So the name of the company is just a throwback to my day spent surfing in Hawaii. Yeah. Yeah, if you ever visit our office, you'll see a lot of pictures of waves and surfing, and people walk in sometimes and they're like, I don't understand. It's not pipelines like Alaskan pipelines. What are the waves? It's just confusing.
So you just a regular design house, or what you doing product?
We have a focus on custom automation equipment. So we do a lot of process development and automated machines, custom fixtures, and we do a little bit of general product development as well. Yeah. All right. So historically, we have done engineering services. That is, a customer comes to us with an idea or a project, and we give them a quote for a project. They say yes, we do the project, all done. Over the past couple of years, we have been working on developing a few of our own products, and one of those, arguably the one I'm most excited about, is called Easy Motion. So I'm going to talk a little bit today about Easy Motion, and I have a demo that I would love for some of you to come up and put your hands on and see if you can get it working. And I'm also going to show a few SolidWorks tricks that we used when we were designing this. Do you need me to stop or pause?
Nope.
All good?
Just trying to make it larger, but
Okay. Okay.
proceed.
All right. So by the end of tonight, I am going to teach all of you to program industrial motion control. Okay. And in fact, I taught a 9-year-old to program automated motion in less than 30 minutes. Now, some of you are going to shake your head at that and say, come on, man, there's no way a 9-year-old is going to learn to program industrial controls in 30 minutes. An adult is going to take months, if not longer, to learn to do that. Well, hold that thought. And by the end of this night, I'm going to make you a believer that anyone in this room can program automated motion with industrial controls. Okay, so a couple of tricks that we used when we're designing Easy Motion. So this is the chassis, the housing of the product right there. And you see all these blue dots in there. Those are threaded inserts, in this case, PEM nuts. And we've been doing this for several years now. Instead of making a subassembly with all of those PEM nuts inserted as parts, we make it as an inseparable part. And for those of you who have done something like this, it's pretty straightforward. You just go to the insert dialog and you go down to the part and you insert a part there, and then you can choose a part from your library. And there are some basic constraints that allow you to kind of mimic assembly mates, right? Like concentric mates and coincident mates and things like that. And then once you have the first one in place, you just use a sketch-driven pattern to place all of the other threaded inserts. So once you have the first one, the rest of them are pretty simple. And then in our drawing, we just call out notes like this. So install the M6 PEM nut McMaster part number, yada, yada, yada. And we do the same thing in the notes at the bottom of the drawing. So those last three there are just our notes that we use, but you kind of get the general, the gist of it here, right? So you might ask, why would you do this as opposed to just creating an assembly that has all of those threaded inserts? And there are some pros and there are some cons as well. So I wouldn't say this is the perfect solution every time. But for us, the big reason is it guarantees that your part always arrives with inserts installed if you order it that way. We prefer not to assemble or to install these inserts. We'd much rather have our vendors install them. They can do it faster and cheaper and better than we can. So we always order these installed. And there have been a few occasions, I'll admit, when we ordered an assembly that had inserts and we just sent them the part drawing and forgot to send them the assembly drawing. So we get our housing or whatever it is, and there are no inserts installed. And that, of course, causes delays and frustration and extra money. So we started doing this to save time and money, avoid mistakes. And now every time we send out a part drawing, we're assured that we're going to get all the inserts because it's part of the part drawing. It also gives you one less part number to deal with. Not a huge deal, but saves a little bit of time and a few keystrokes. And it's one less drawing to create. You know, these drawings, admittedly, are not huge drawings. Probably take you 15 minutes or something to put together that drawing. But hey, now that's 15 minutes that you can spend doing something else. The con is that the notes that we use in our drawings, they're just dumb notes. So install M6, PEMNUT, McMaster, yada, yada, yada. It's just a dumb note. And if that part changes, the part properties are not going to automatically filter into that note. So you do have to be a little careful there. And that's definitely a downside of this approach. Any questions about the inseparable assemblies in a part model?
Couldn't you turn it into a logo and use properties?
I don't know. Could you? Okay, great. Even better.
Because the logo has the cut list, that's how we tried it.
You know what? I think we do that actually. Yeah, when I opened up this part, I did notice that there was a cut list in it. Yeah. But I think the custom properties still don't propagate their way into a note. You can do that also? I'm gonna have to talk to you tonight.
It's still a little harder and stuff, constantly.
Yeah, you need to make sure it updates all.
Yeah, okay. Yeah. And using the quote unquote assembly mates within a part is a little clunky. It's not awful, but it's not as clean as within a normal assembly. But for us, it's been worth doing this because we always get parts that have inserts installed. It has eliminated that problem, which was the main challenge for us. Any other questions about that? Okay. All right. So another thing that we've done a lot is we've created a sketch out of our company logo. So down on the bottom right, you can see our company logo, Pipeline Design and Engineering. And then this is looking at the bottom of our Easy Pneumatics controller, which is what's sitting up there on the table right now. And you can see that we have a pipeline logo there. It's really kind of an air vent. And we thought, why not make it a pipeline logo instead of some boring holes? So that's what we did. We have a sketch that is that shape of our logo, and we've had this for many, many years, and we've used it a ton. It's just in a folder where all the kind of SolidWorks library tools are, and we can very easily just drag it into the model and drop it in place. To create a logo like that or any shape, if you have access to Adobe Illustrator, it's super easy. I don't know how to use Adobe Illustrator, but I can use it to make a DXF of an image. I'm not going to go through the details of how to do that, but if you just Google how to trace logo and export DXF file from Adobe Illustrator, you'll find plenty of tutorials on how to do that. And it's literally like 2 or 3 clicks. You bring an image into Illustrator, there are a couple of buttons you push, and voila, it gives you this really nicely traced outline of your logo. And then you just export that as a DXF and pull it into SolidWorks.
If I may contribute really quickly.
Please.
Inkscape is a free version of Adobe Illustrator kind of.
Okay.
Source. So for those of you that don't have Adobe Illustrator, look up Inkscape, kind of like landscape or anything. It's an open source project, and there's a lot of YouTube videos on it for auto trace as well. That will give you a background of your actual.
Awesome. Awesome.
For what it's worth, I think there's a SWUG topic from a couple of years ago that's on our YouTube page that I think shows a couple of ways of creating the DXF as well.
Yep.
Essentially use.
Cool.
Anyone needs that.
Yeah, I can't tell you how many times we've used this. We're a custom machine builder, so we're always building new machines, and we seem to always find an opportunity somewhere to drag this logo on and have a little bit of branding in the machines that we send out. And then another pro tip is make a block out of it. Don't just leave it as a sketch, but turn that sketch into a block, because it allows you to scale that logo much easier without having to, try and change all these different dimensions.
Plus, it's a complex sketch, so the user.
Exactly. Yeah, if you've got a lot of lines and some splines and things like that in there, then it just locks everything in place and lets you easily scale it up or down. Okay, last pro tip. This one just tickles me so much. I love it. How many of you have set up SolidWorks brand new, like on a new computer? Raise your hands. A few, okay. So you know that setup process where you need to go into your system options and the file locations, and then there's that drop down, and there's all these different options in there, right? The BOM table, color swatches, custom appearances, which are all set by default. But what if you don't want to use those defaults? What if you have your own library of files that you want SolidWorks to point to? It's not simple to understand where SolidWorks keeps all of these things, right? They're kind of scattered. There's no intuitive organization of them. So what we have done is create folders in Windows Explorer. We have a folder that we use called SolidWorks File Locations. There you can see it right there. It's just in Windows Explorer. And then in that folder, we create all of the folders that match the different drop-down items in the file location. So I'm going to go back here so we can reference that one. All of these items that you see in the drop-down, we have a folder for those right here. And now it's super easy to find the folder that contains the files that you want. So we actually don't use all of those folders. A lot of those settings we just leave as the SolidWorks defaults, but there are, I think, 5 or 6 that we always change, like the BOM templates, the custom properties, sheet format, a couple of others like that. And now you just have all the folders organized in one parent folder. You know exactly where everything is, and it's really, really easy to keep them all organized and find the files that you're looking for. Any questions there? Okay. All right. So that concludes the pro tips that we used as part of the design for our Easy Motion product. Let's see. I have a video that I want to play. I hope the volume works. Oh, it's not liking that. Do we have any IT professionals in here? How can I play volume?
Same procedures actually. Plug that in. And
You don't have a,
oh, you don't have normal
you don't
USB?
have, if you
Well,
can't get the
perfect.
volume to work, then no big deal. I'll just play with the volume.
That's all right. Adapter right here.
Ah, thanks.
Plug that in. Should be able to connect that to your computer, and this is a pretty loud speaker, so this should work.
Okay.
Yeah, I think that's gonna work. So there's supposed to be audio going right now?
Not yet.
Okay.
Okay, I'll test real quick.
Easy Motion is
Yeah,
the fastest.
Okay, cool. All right. So Easy Motion is they're motion controllers. And we have one for motors and one for pneumatics. We've had constraints in the past internally at our company where we have an in-house controls engineer, but sometimes his capacity gets exceeded. And now we have engineers who are trying to develop a new process for some automated machine, and they can't make progress because they need help programming to test out some automated motion sequence. So we wanted to come up with a solution for this internally so we could make more progress. And Easy Motion is what we ended up coming up with. And now we've just made it into a product that we sell. So there's a controller for motors, it works with stepper motors, and a controller for pneumatics, which works with pretty much any type of pneumatic actuator. There are different I/O for digital I/O, analog I/O, so you can plug sensors into this thing and use them to trigger different motions. You know, when this sensor goes high, move cylinder 3, whatever. When the force from this force gauge exceeds 2.8 pounds, move motor A to this position, things like that. And it's super easy. I'll show you the interface after this, but I'll play this quick video. It's an overview, and you'll kind of get a sense for what it is.
Easy motion is the fastest, easiest, and most cost-effective way to automate motion for R&D and manufacturing teams. Requiring absolutely no programming experience, its key advantage is the hyper-intuitive drag-and-drop software interface. Simple enough for a novice, yet powerful enough for demanding industrial tasks. You'll be running your first automated motion sequence in less than 20 minutes. We've also eliminated the hours spent sourcing and wiring together components like power supplies, terminal blocks, and solenoid valves. Our pre-integrated industrial control boxes support electric motors, pneumatic actuators, sensors, and other field devices for a seamless plug-and-play experience. Democratizing automation for non-programmers, Easy Motion replaces complex control systems that few team members know how to use. Say goodbye to waiting on overburdened internal controls engineers or paying premium rates for external help. Now anyone on your team can create and refine automated motion in a fraction of the time it takes even a seasoned PLC programmer. Whether you're automating R&D processes, conducting cycle testing, or developing new manufacturing workflows, Easy Motion lets you skip the low-value busy work and achieve results 10 times faster. Focus on innovation, not setup. Get started today with Easy Motion, revolutionizing automation for R&D and manufacturing teams.
All right, so when I said that I taught my daughter how to program automated motion in 30 minutes, this is what I was talking about. And in fact, in under 30 minutes, she had put together her own motion sequence. We did a fun video of that. It's on LinkedIn somewhere. But let me show you what the interface looks like. Full screen here. So it's just a drag and drop interface, and you can select pneumatics or a motor or both. I've just got the pneumatics controller up there, and I've got a little challenge that I'll issue. And if anyone wants to come up and try to create this automated motion sequence, I would love for that to happen. I did not bring the motor one with me. I just have the pneumatic controller. Anyway, how you use this is we have these blocks on the side. And if you want to actuate an air cylinder, you just drag the block in there. It makes a nice click sound. And then you tell it, I want it to extend or retract. If you have a position sensor in your pneumatic actuator, as many pneumatic actuators do, you can click this wait for sensor button, and then the system will wait until that action has been completed before moving on to the next action. Maybe you have a bank of different pneumatic actuators and you want to simultaneously actuate a few of them. You can drag in a block like this, and maybe they're already extended and you want to retract them. And you want to wait until number 4 sensor triggers, but you don't really care about number 3, so you leave that unchecked. And of course, we need to wait for something else to happen. So we're going to drag a wait block in there. Just like this. And we can wait for, I don't know, how about 5 seconds, something like that. There are also some different, is it frozen? Uh-oh. Maybe I can, let me try unplugging this and, oh, there we go. There we go.
Yeah, weird. I don't know why it's so delayed.
Okay. Yeah, there's a pretty significant delay. Anyway, there we go. A variety of other blocks in there. There are logic blocks. So if you want to do an if-then statement, you can do that. You can do repeats, you can do while something, do something else. And then of course, for motors, we have similar blocks. So if you're just using a motor and want to spin a motor shaft, that's easy. But if you have, for example, a slide and a motor connected to that slide, you can just pull blocks in there, moving a motor on a slide from position A to position B, changing the speed of the motor. What else? Those are the basics.